Welcome back. This is video 2 or section 3, fully connected or dense layers. In the previous video, we explored new ways to improve our plots. In this video, we will see what it takes to define a layer in Keras. And later, we will see the details of implementation of the dense layer, how to initialize it, and how to use it. I have a Keras layer skeleton. A Keras model expects that a connected layer has the following method: init, where we get the layer parameters; build, where we allocate and initialize the space in memory reserved for the trainable weights of the layer. Note that all the parameters are stored in a list. Later, we will calculate the gradients of the cost function with respect to the parameters. In the model's compile method, do you remember? Get_output, which uses the default get_input of the layer class and transform it using the parameters to generate an output. That output will be referred by the getInput method of the next layer. And finally, output shape, that tells the next layer in the model what is the size of the tensor returned. Moving here to our IPython notebook, back to the model that we defined in the previous video. So let us check out how this dense layer works. We are here on Keras repo on GitHub, and the dense layer is inside Keras, layers, core, and here we look for the class dense. Here it is. Jumping to the getOutput method, which is right here. The dense or fully connected layer, as you can see, is the classical neural network layers. And it simply calculates the inner product of the layer's input x with the synapses W and summit bias B. And after that, it calculates an activation function. This function can be, as we already mentioned, the hyperbolic tangent or the rectified linear unity. It is always important to repeat that the output of the layer is a symbolic variable, either a Theano or a TensorFlow variable. It does not have any value. It can only be used if compiled with a proper compilation method. In our case, Theano.function. Above here, we can see that the output shape method is equal to the first dimension of the input shape, and the second dimension equals to the output dim that we define to this layer. So this motivates us to see what we have to ask in this layer's init method and what we have to instantiate in the build method. Up here on the init method, the required value that we have to pass to this layer when initializing it is the output dim, which is the number of neurons in the output. We just saw it. Essentially, this is to calculate the shape of the matrix W. The number of rows is equal to the number of columns in the input, and the number of columns of W is exactly this output dim. If this layer is the first one in the model, we also have to pass it the input dim. From the second layer and on, the input dim is defined as the output dim coming from the previous layer. Here on the dense layers init method, we also have other definitions such as the activation function and regularization parameters to bound the possible values that the layer weights may assume during training. Finally, down here, the build method defines and instantiates the weights W and the bias B. This list, self.trainable weights, is what defines which variables will be adapted during training. To be adapted, a parameter should be both used in the getOutput method and be an element of the self.trainable weights. Keep that in mind when creating your own Keras layers. These other lines of build initialize the regularizers. In this video, we saw how to define a layer in Keras and how to implement a classical neural network layer. In the next video, we will understand how convolutional and pooling layers work.